We physicists have held up 100 years, beginning around 1916, for this photo. It is a locale where dark openings may very well be one of the most captivating and strange peculiarities in the universe. They are gigantic monsters in terms of power, and yet basically imperceptible to us. A dark opening gauging maybe 2 to 4 million times the mass of the Sun. But because of the research that was placed into them over the last couple of decades, we've gone from knowing literally nothing about them to getting to find out more and more very close and personal. And while things have simply gotten more insane, Kaku recently reported that we at long last got a glance at what's inside a dark opening. This new data sheds light on the subtleties the universe of science could have missed from the beginning. Join us as we dig deeper into dark openings and uncover what's inside. Space is enormous, but what are dark openings? Before we get into the subtleties of what Kaku found, we need to discuss the primary. Despite the fact that the vast majority of us have some idea of what dark openings are, there are still a few gaps in the justified data. You see, in 1916, Albert Einstein published his theory of general relativity, which predicted the existence of dark openings. At that time, the idea of dark openings was purely hypothetical. It required an additional 50 years for the scientific community to find evidence that dark openings actually exist. This occurred in the 1960s when they were examining the Cygnus constellation and saw a strangely dazzling blue star that was emitting X-rays. This star was definitely not a stale object but was instead orbiting a giant dark something. Upon further examination, it was observed that the X-rays weren't just moving around on their own but were being sucked into the dark thing they were orbiting. Consequently, the name dark opening was coined. This discovery was critical because it provided proof that dark openings actually exist and that they were not just a figment of Albert Einstein's wild imagination. While that was great, it also meant that there was this incredible entity in space that we desperately needed to learn more about. So, researchers from around the world got to work. This dark opening was named Cygnus X1, and it is located in the constellation Cygnus, around 6,000 light-years from Earth. It was no small discovery. It's multiple times brighter than the Sun and incredibly dense, which gives it a strong gravitational pull. The gravitational pull is so strong that not even light can escape it. This is why it is known as a dark opening. The idea of a dark opening is both captivating and terrifying. It is a region of space where gravity is so strong that nothing, not even light, can escape. Whatever gets too close to a dark opening will be pulled into it, gone forever. Yet, that element of danger makes it even more important to learn everything there is to know about them. Was this it? Or were we just beginning? The answer ended up being the latter. After the discovery of Cygnus X1, researchers started searching for other dark openings. They found that there might be over 100 million dark openings in the Milky Way alone. But because they are so incredibly hard to detect, we still don't have an exact number. Nonetheless, from what we can tell, there are several million dark openings in the Milky Way in our very own universe, making them even more significant to study. So let's break it down. The main concern with dark openings is always going to be gravity. Their gravitational pull is so intense that anything that enters it is compressed down cosmically until it becomes a singularity. In simpler terms, dark openings are like cosmic vacuum cleaners that suck everything in. One of the most terrifying aspects of the research into dark openings is the fact that if someone were to fall into one, they would reach a point where they become a single line. This process would happen slowly, and the person would die before the final form sets in. So, let's just say that no one should step into one. But they are everywhere, so could we really be in danger? Despite the fact that the nearest dark opening to Earth is about 500 light-years away, it's still close enough to raise concerns. In 2021, researchers were able to produce the first clear photo of a dark opening. Specifically, the M87 dark opening. This dark opening was photographed several nights in a row, and with each photo, the experts gathered more and more evidence about it. They had to combine the individual photos together to create something that filled all the gaps. This way, they were able to determine that there are 3 layers to a dark opening. It's not just one single expanding hole of nothingness, as many people believe. Things are much more complicated than that. To even get to the nothingness part of a dark opening, you must pass through the first 2 layers. The first layer is known as the event horizon. Once you pass the event horizon, there's no turning back. You will be sucked into the dark opening. The layers only get worse from there. The second layer is the photon sphere, the region where light circles the dark opening. Any light that enters this region will be trapped and cannot escape the dark opening's gravitational pull. Finally, we come to the third layer, which is the singularity. This is where everything that enters the dark opening gets compressed cosmically until it becomes a singularity. The singularity is a point in spacetime where the laws of physics, as we know them, break down, and we cannot predict what happens next. At the singularity, the density is infinite, and the laws of physics, as we know them, cease to exist. What makes this even worse is the fact that every single dark opening you study will be completely different from the last. Sure, they tend to follow the same three-layer concept, but how they function could be vastly different. If this were anything else, all we'd need to do is get back on those telescopes and study the main concern in detail. But with dark openings, you can't really do that. Scientists can only study dark openings indirectly by observing the radiation they produce and the gas and dust surrounding them. Sending a probe, like the Voyager, inside a dark opening is impossible because anything that enters the event horizon is pulled toward the singularity, where it is compressed to an infinitely small point. So, you can't exactly spend billions of dollars just to get a glimpse because the moment the probe gets close enough, it'll be crushed into nothingness. Due to this glaring problem, scientists are left with no choice but to study these objects in a two-dimensional way, even though they are three-dimensional peculiarities in reality. To make matters even more challenging, there are also the issues of every dark opening being unique and the laws of physics, as we know them, breaking down when we try to investigate the inside. This means that the traditional methods of scientific inquiry don't really apply to the study of dark openings. That doesn't mean that scientists haven't been busy. There are many different theories and explanations of dark openings, and with each one, things get more and more interesting. One of the most compelling theories about the formation of dark openings is that they are created from collapsing stars. When a star exhausts its fuel, it can no longer produce enough energy to counterbalance the force of gravity constantly pulling inward. As a result, the star begins to collapse in on itself, becoming smaller and denser as it does so. If the star is massive enough, this process can continue until it becomes a singularity. To understand the nature of dark openings in more detail, NASA scientists turned their attention to the center of the M87 galaxy. Astronomers observed a powerful whirlpool of extremely hot hydrogen gas spinning at an astonishing speed of 1.2 million miles per hour. The sheer force of this spinning disk of gas should have caused it to fly apart wildly, but it didn't. Scientists concluded that there must be a massive object at the center of the galaxy preventing this from happening. This gigantic object weighed as much as 2 to 3 billion suns and must be a dark opening. But that's not the only theory where dark openings spin. In 1963, the New Zealand mathematician Roy Kerr used Einstein's equations of gravity to provide the best description of a spinning dark opening. Kerr showed that a spinning dark opening wouldn't collapse into a point, as previously thought, but into a ring of fire or a thin disk. The disk would be spinning so fast that centrifugal forces would prevent it from collapsing. This spinning disk of matter is called the ergosphere, the region surrounding the dark opening where the laws of physics begin to break down. Yet, the most intriguing feature of Kerr's solution was that it predicted the existence of an Einstein-Rosen bridge, also known as a wormhole. This is a theoretical passage through spacetime that connects two separate regions of the universe or even two parallel universes. The idea is that if one were to fall into a dark opening, instead of being crushed to nothingness, one would be sucked down a tunnel through the ring of fire and shot out of a white opening in a parallel universe. To understand how this works, we need to look at the concept of spacetime in Einstein's theory. Space and time are not separate entities, but are interconnected, forming a four-dimensional fabric called spacetime. Objects with mass warp this fabric, creating a gravitational field that causes other objects to move toward them. Now imagine a sheet of paper representing spacetime. If you put 2 points on the paper and draw a line between them, this represents how objects move through spacetime. But what if you could fold the paper in half and create a shortcut between the 2 points? This is the fundamental idea behind a wormhole. It's a shortcut through spacetime that connects two distant points in an instant. Wormholes aren't just a science fiction concept. They are a real possibility according to Einstein's theory of general relativity. However, no one has ever observed a wormhole, and it's not clear whether they exist in reality. If they do exist, they could potentially allow for faster-than-light travel and even time travel. But before you get too excited, there's a catch. To keep a wormhole open, you would need something called exotic matter, which has negative energy density. This type of matter doesn't exist naturally and would have to be created somehow. Even if we could create exotic matter, the amount needed to keep a wormhole open would be enormous, far beyond our current technological capabilities. So, are we going to be able to travel through dark openings and visit other parts of the universe? Probably not anytime soon, if ever. The idea of using dark openings as a means of travel is still purely theoretical, and the challenges involved are immense. But that doesn't mean we should stop studying them. Dark openings are one of the most fascinating and mysterious phenomena in the universe, and they have the potential to unlock new insights into the nature of space, time, and gravity.